Welcome to the 6th video in Unit 6. We're going to be finding the area between a piecewise function and an axis. We'll need to review the geometric area formulas, and I'm going to introduce some notation that goes along with this topic. Right here we see the curve or the line y equals 1/2 x goes through the origin and has a slope of 1/2, up 1/2. So here you can see the red line here. You see the x-axis, and you see that from 0 to 6 on the x-axis, if I just want to find the area, the blue part between the graph and the axis, it's in the shape of a triangle. All right, and we know that the area of a triangle is 1/2 base times height. Well, the base of this triangle is 6. The height of this triangle can be found. It is 3, right here. So I would have 1/2, 6 times 3. The area is 9 units squared. All right, so you can see this interesting little notation here. It says over the interval of 0 to 6, using this curve, and this is just calculus notation, which you'll learn more about next year. This is my function, right? Y equals 1/2 x. This means find the area between this and the x-axis. X-axis. Okay? So all you're doing is just finding the area of that shape, but that's what this means, between x equals 0 and x equals 6. All right, so here's a little bit more about the notation. For this that we just saw on the previous page, we have this funny little mark here. It's an integration symbol from A to B, and you can see here's A and B are intervals. F of x is a function. dx just means that is a calculus symbol, and you'll have to learn about it next time. I'm not going to get that deep into it. So this right here means find the area bounded by f of x, the x-axis, and the vertical lines x equals a and x equals b. So here's x equals a, here's x equals b, right, from A to B, and this is also in the shape of a triangle. So the area is 1/2 base times height. Now, the functions, which you're not really seeing the functions, but this is f of x, which is a line, but you can see that between 2 and 6, it's not a triangle, it's a trapezoid. And the area for a trapezoid is 1/2 the height of the trapezoid, and the height is right here. This is the height. And then you add the two bases, base 1 plus base 2, and multiply that in there. So this is base 1. This right here is base 2. So we did 1/2 times 4, that's the height here, 1 and 3. Add that together, 4 times 4 is 16, so this is 8. And this would be units squared, don't forget your units. Okay, this is a semicircle. It has a radius of 5, which I can just find by counting, right? So it's half a circle. Well, the area of a circle is pi r squared. So half a circle would be 1/2 pi r squared. So this would be 25/2 pi units squared. Now, this is the exact form. If I wanted the approximate form, I could put that in a calculator and get it. This is sufficient for now. A rectangle. My interval is from -3 to 4, and then up 1, 2, 3, 4, 5. Right? So to find the area of a rectangle, you would add 3 plus 4, that's 7. The area of a rectangle is just base times height. So we have the line y equals 5, we have x equals -3 and x equals 4, and the x-axis. So if I went back and wrote the integrals for each of these, for the trapezoid, it would be the integral from 2 to 6 of f of x dx equals 8. For the semicircle, I would have from -5 to 5 of the function semicircle dx equals 25 over 2 pi. And the last one is the integral from -3 to 4 of f of x dx equals, do we find it? 7 times 5 is 35. Okay, if we wanted to find the integral from 0 to 24 of v of t dt, we're going to divide these areas into pieces and add them up. So this triangle right here is 1/2 base times height. Okay, and then I'm going to add to it this, looks like a rectangle. So I have 12, this way is 12, and then still 20 high, plus this is a triangle, so 1/2, from here to here is 8, and from there to there is 20. So I have 40 plus 240 plus 80, so 120, 280, 360, I think that's right, yeah, 360 units squared. So if I go back up here, the integral from 0 to 24 of vt dt is 360 units. We're not going to do all of these. This is a calculus problem. But what you're trying to find is the signed area between the curve and the x-axis. So a couple of things I wanted to note here. If the geometric figure is above the x-axis, then the actual area is positive. If it is below the x-axis, it's negative. And I'm not going to have any where you're going to have to find the negative and add them up. That's calculus, and you'll do that next year. But what I want you to get the idea is being able to find, for instance, this one. This area right here from 0 to 6 is number 1. This piece right here from 16 to 18 is not written on here. So say, for instance, I wanted to find from 16 to 18, I want the area. You could find that pretty easily because you have, it's just a 1/2. The base is 2, and the height of this is 15, right? So this is just equal to 15. If I want to find this one, like say for instance I want to go from 0 to 2 of f of x dx. 0 to 2 is just a rectangle, so it's going to be 2 times 15, which is 30. So what is it from 2 to 6? Well, 2 to 6 is a triangle, right? From 2 to 6 is a triangle. It's hard to see, but from 2 to 6, this is 4, and this is 15. So this is just 1/2, 4 times 15, which is 30. So what is it then from 0 to 6? Well, from 0 to 6 would be 30 plus 30, which is 60. So I hope you'll see that these are just intervals, and the integral of that is just finding the area underneath the curves. So here's another problem. This is putting it all together. You're going to draw the line y equals 1/2 t plus 4. T is going to be instead of x. And use geometry to find the area under this line. So let's graph the line, 1, 2, 3, 4. The slope is 1 over 2, 1 over 2, 1 over 2. So if I draw this line, right, okay, and I want from -4 to 4, okay, and then find, I want to find this area in here. So in other words, I'm finding from negative 4 to 4, 1/2 t plus 4, and we'll call it dt this time, equals, and that's my answer. All right, so it looks like a trapezoid. 1, 2, 3, 4, 1, 2, 3, 4. So this is 8, this is 2, and this is 1, 2, 3, 4, 5, 6. So 1/2 height, and then 2 plus 6. So 64 divided by 2 is 32 units squared. So we used graphs that had straight lines back and forth, or semicircles, or things like that. But this is calculus. This is what you do in calculus. So if you had a sine curve, right here, a sine curve, you could find the area using calculus. If you had the square root where it's curved under here, you could find it, or even under a parabola where it's curvy instead of straight. This is what you'll be doing next year in calculus. All right, so I'll see you in class.